Yes. Okay, so hi there. We're going to continue with our videos in the conditional probability. The last part of the conditional probability part is actually here. Sorry for that. Multiplicative rules. So let's get into it. Let's try to recall our keywords for set operations. So in probability, we have this. So for example, let's consider A to be getting an ace, B to be getting a king in a 52, in an ordinary 52 cards um, deck of cards. Consider the probability of A union B. We are using the word or here. That's why we're using the additive rules when we're having this union or the operation basically is plus. So it's asking about the probability that either A or B will happen. So for example, what's the probability of getting either an ace or a king in a single draw of cards? And the operation regarding this is the plus or the addition. When we try to look at the intersection, we want to actually know that they're both happening at the same time. So the word here is and we're talking about the probability that both A and B will happen. Both of them will happen. And we use a statement, the probability of getting both an ace and a king, and we use the operation multiplication for that. And of course, the complementation, which is not A, the probability of A complement, which is not. So the probability of that A will not happen. We can use with B with that as well. Then use that with B. The probability of not getting an ace, and we are doing the complementation or 1 minus the probability of this certain event E. So in this case, the probability of A complement is equal to 1 minus the probability of A. So we're going to focus on the multiplicative rules, which makes use of this word and we're going to work out the probability that the two events happen at the same time and their intersection um, most specifically. So this will enter our topic in what we call multiplicative rules. It's they are used to find probabilities of two or more events that occur in a sequence, or they can occur all together, but mostly if they can occur together, you can imagine them to be occurring in a sequence. For instance, if we're going to find the probability of selecting three jacks from a deck of cards on three sequential draws, so you draw in a sequence. Before explaining the rules, it is necessary to first identify and determine and understand the concept of independent and dependent events. So let's start with the idea of dependent events. So given two non-mutually exclusive events A and B, so they have an intersection. The product or the probability that both A and B will occur in a sequential manner or all together is the probability of A happening and then probability of B given that A already happened. What happened to this second term here in the probability series is that we are respecting what happened already because this is the first sequence. You can imagine this is the first draw, the first toss. So in the first toss, say they are dependent events. So whatever happens in the first toss, the second toss is affected by it. So that's why we say the probability of B given that A already happened because it did. Okay. So this is the probability of dependent events. And if we can also get that in a different manner wherein we can get the probability of B first. And of course, we want to respect the given event that occurred already, probability of A given B. Take note that intersections are commutative. So A and B are considered to be dependent events since the first equation, the probability of B is influenced by the occurrence of A's. Similarly, in the second equation, the probability of A is influenced by the occurrence of the first event, which is E. For example, two supervisors in a company are to be selected as safety representatives within the company. Given that there are 6 supervisors in research and 5 in development, and given that each group of these two supervisors have the same chance of being selected, find the probability that both of the supervisors will be from research. So what you're going to do here is we're going to look at the research number of supervisors. So there's a need for two supervisors only to be representatives. So we have six supervisors from research. So the probability of getting in the first draw or in the first picking, shall we say, we have six supervisors divided by overall 11. So that's the first term. We're going to multiply this term into the second one. The second one is still, it's going to be still from research. So imagine that we have already picked a single person from research. So this 6 will become 5 because 1 has already been chosen from research. And our sample space, instead of 11, it will become 10 because 1 is already or has been already chosen. So we're going to multiply it in this manner. Notice they are dependent because the second event is dependent to the first event happening. So this becomes 30 divided by 110. Of course, we can simplify this into 3 over 11. Okay? And that's our answer for this number here. All right, so if it's not clear for you, you can just repeat the explanation in the videos given here. Okay, next. Let me clear this out. Now, if dependent events are the ones that, the next event is affected by the previous one, we have, of course, what we call independent events, wherein the occurrence of the first event has no effect on the occurrence of the next event. So therefore, when we say we can actually say that they're independent if the probability of A given some event B is just equal to the probability of A alone. So meaning it's not dependent on B because it's not really giving you a change or a difference. So meaning even if with B has occurred or without B, there it's the same. So if these are not the same, therefore that's the time that we call the events dependent instead. Okay, for example, so getting a head on the first toss of a coin and getting a tail on the second toss of a coin. Remember when we toss a coin, they are independent because the first toss or the second toss is not dependent on the first toss. Whatever happens in the first toss, it is not affected by what will happen in the future. The first customer who enters a store makes a purchase, and the second customer makes a purchase as well. So, provided that the purchase that they have bought have enough supplies, so therefore they are independent events. So what are the multiplicative rules for independent events? So if they are independent, things are a bit easy because you simply just need to multiply event A and event B. Again, notice that event B given A, if they're independent, is just equal to probability of B. Therefore, you don't need to write the given or the conditional probability. So for example, a service station manager knows from past experience that 60% of their customers use a credit card when they purchase gasoline. What is the probability that the next two customers purchasing gasoline will each use a credit card? So this 0.6, you just need to multiply it by itself. It will become 0.36. So there's a 36% chance that the next two customers will pay via credit card. The next customer is not affected by the first customer because well, provided that they have credit cards and provided that the gasoline will not run out on that second purchase. Okay, so they're not affected. So just simply multiply it. All right. So that's the end of conditional probability. I hope you learned something from these videos. More examples will be given in the modules, I guess. And that's it for now. Thank you very much for watching and hope you learned something here. Okay, goodbye.